This puzzle is called Not With a Revolver by MicroStudy. I got it from the CTC community Discord, the Sudoku testing submissions channel. Let's take a look at the rules. So 9 by 9 puzzle, non-consecutive, so that means that you cannot have consecutive digits next to each other. So if this was a 3, we couldn't use a 2 or a 4 in any of these cells. A 2 here would break the puzzle. 4 would also be bad. Yeah, it's pretty. That's a pretty simple but powerful rule. Simple as in not complex, not easy necessarily. Digits within a killer cage must not repeat and must sum to the to the number in the top left. So these 3 digits add to 7. These 5 digits, these 5 digits add to 33, and so on. Digits can't repeat, but I don't think that really matters here since digits can't repeat anyway because they're always in the same box here. Okay, I'll put a link to the puzzle down in the description. I don't know how hard it is, but yeah, let's get going. So the first thing I see, this must be 1, 2, 4. This must be 6, 8, 9. That's just the only way of making 7 and 23. But now we have to remember the non-consecutive. Maybe if I highlight it, no, it won't say highlighted. But this could not be a 1 or a 2. If we tried to put a 2 here, then we couldn't put a 1 in either of these cells. Same goes for if we put a 1 here, then 2 would be ruled out. So this must be the 4 to kind of buffer between the 1 and the 2s. Similarly, this must be a 6 to buffer between the 8s and 9s. What's left is 3, 5, and 7. This could not be a 7 because it would be next to... One of these is going to be an 8, so this can't be a 7. Similarly, one of these is going to be a 2, so this can't be a 3, so this is a 5. And I guess once we find out more about these, it'll tell us about the arrangements of 1, 2s, and 8s and 9s, but not quite yet. Over here, this must have a 9 in it. 22 must have a 9 in it, and 8 must have a 1 in it. You know what might be handy is if I look at options, because I should have brought this up earlier, but looking at the various options for cages is actually going to be more important than usual, because non-consecutive actually rules out some options. So for example, this 21 cage typically could be 6, 7, 8. But with the non-consecutive, we can't do 6, 7, 8 because no matter what we put here, if we do a 6 here, one of these is going to be a 7. 7 here, well, these are both bad. An 8 here, one of these again has to be a 7. So 6, 7, 8 doesn't work. So this actually has to have a 9 as well. It has to be 4, 8, 9 or 5, 7, 9. Which is then going to put a 9 up here because we need a 9. We need a 9 in column 7. And similarly, 9 typically could be 2, 3, 4, but because of the non-consecutive rule, we can't do 2, 3, 4, so it must have a 1. It's either 1, 2, 6 or 1, 3, 5. And so we need a 1 in column 3, which is going to put a 1 down here. I imagine these 5 cages are going to be pretty restricted as well. Let's look at 17 first. Let me bring up Notepad so you all can see it as well. Oh, I actually have to make Notepad show, don't I? Whoopsies. There we go. Okay. So these are the 2 options typically for a puzzle like this. Or so typically for a killer cage, I mean. But is one of these maybe not actually allowed? I think 1, 2, 3, 5, 6 might be a problem. If we put a 1 here, one of these will be a 2. If we put a 2 here, one of these will be a 1. If we put a 3 here, one of these will be a 2. Put a 5, well, that can't be a 5. But even if we could be a 5, one of these would be a 6. Yeah. There's always... This one just doesn't work. So this must be 7 and then 1, 2, 3, 4. And the 7 has to be the buffer all the way around. Which then puts a 6 over here. I guess this can't be a 4 because of that 4. That 6 puts the buffer in. Okay. So now let's look at 30. What was it, 33? Where'd my options go? There we go. No, Notepad, come up here. Call number. I don't know if that option popped up. I don't know. Windows assumed I was typing a number, I guess? I don't know. No, I'm doing Sudoku. I don't need to call anybody. So yeah, again, 4579 would cause problems. Because no matter what we put here, there'd be a consecutive digit next to it, so it must be 36, which is going to end up with 3 in the middle. And that can't be a 6. Neither of these can be 7, so one of these is a 7. Similarly, neither of these can be 3, so one of these is a 3. And actually, one of these is a 6, so neither of these can be 6. And one of these is a 4, so this can't be a 4. And then 4 can't go there, so one of these is a 4. Okay. Okay, yeah, I think that's all good. I think we go to probably the 8s. So 8 is either 1, 2, 5 or 1 through 4. So what's going to be the problem here? If we did 1 through 4, let's just see what happens if we try to put 1 through 4 in here. We have this 3 pointing over here, so this can't be a 3. So this is the 3. This would be a 1. This would be a 4. That looks fine to me. I mean, it doesn't break. I don't need to go necessarily 15 steps down the rabbit hole, but 1 through 4 seems to work. What about 1, 2, 5? 5 would have to be in the middle, so separate the 1 and the 2. That actually seems to work as well. Maybe that causes problems over here for the 13 cage, though. Where... For some reason, I cannot keep track of where I'm keeping my options. Does that somehow affect the 13 cage since it couldn't have 1, 2, 3? It would... I guess this would be minimum 4, 6. And then this would be a, 3. That would be just fine. This could even be 4, 8, and a 1. Yeah, I don't think that's a problem. So what am I missing here? Let's get this stuff back up. Okay, Maybe look at the 9. I guess we can put that back. Want to look at the 9 cage. So 9 is 1, 2, 6. Whoops. 4, 1, 3, 5. Whoops, let's just be clear about this so we understand what we're talking about. I think this was the 13. So, 9 cage could be 1, 2, 6. Is that a problem in any way? I don't think so. The 6 has to go in the middle to buffer the 1s and the 2s, but that seems to look just fine to me. Okay, what about 1, 3, 5? This becomes a 5, and this becomes a 1, 2. Sorry, a 1, 3. Looking over at the 1, 2, which makes that a 2, but that's not a big deal either. Do we have to somehow look at these in combination, maybe? Would, like, making this a 1, 3, 4 somehow break the 1, 2, 6 or something, or both options? Whoops, that's not what I wanted to do. 1, 3, 5. This would have to be a 5. So it couldn't be 1, 3, 5. And this has to be a 6. This would be 2, 1. This seems to work just fine to me. Yeah, this seems to work just fine to me. Maybe there's something else that I'm missing before I come over here to this, because that seems a little more extreme. I guess 5 is restricted to down here and up here. Oh, I know what's wrong. I'm dumb. 1, 2. This couldn't be a 1 or a 2. If this was a 1 or if this was a 2, this would be a 1 and we would break the puzzle. This must be a 4. Similarly, this must be a 6. Sorry about that. Had a quick distraction. Where was I? The six. Yeah, this. What was I doing? Yeah, this must be a six because it couldn't be eight or nine. Yeah. So now where can five go? Must be down here. Same five must be up here. Uh, one and two. I guess this is just a one or a. Outside of this cage is 1, 2, 4, and 5. This can't be a 4 or a 5, then this must be a 1, 2, which gives us a 1, 2 pair, which puts that there. Similarly, this must be an 8 or a 9, because outside the cage must be 5, 6, 8, and 9. And if it's not a 5 or a 6, it must be an 8, 9, which gives us an 8, 9 pair, which makes this a 7. Yeah, I didn't think that, like, looking at these cages in conjunction was what we were going to need to do. I'm glad I stopped doing that. So this 7 looks up and makes this a 3 and a 7. 1, 2, 9, 8 to just respect all the non-consecutivenesses. Consecutivenesses? Something like that. Oh, this can't be an 8 anymore because we have a 9, so this is a 9. No, this one can't. I was thinking 8 nines, but no, it's the opposite. We're kind of reflecting and oppositing. This can't be a 2, this is a 1. So this is 2, 4, 5. This can't be a 2 or a 4, so this is a 5. This is a 2, 4. I don't think we get anything there. This is, oh, we have a 9 right here. This is an 8, this is a 9. We have a 1 right here. This is a 2, this is a 1. Yeah. So this is a 5. Now we have, whoops, what did I click over here? I thought I hit delete and it didn't delete. We have an 8 and we have a 6. No information there. Okay, but now we can come back over to this 8 cage and say, how could this possibly be 1, 3, 4? Because we have 1 and 3 pointing in. This would have to be 1 and 3. It's not 1, 3, 4, it's 1, 2, 5. The 5 must go in the middle to buffer, and then this can't be a 1 because of the 1 here. We can do that. This can't be a 1 because of this one. But let's just keep doing the reflectiveness. This must be a 9 because we have the 9 looking over. And now this can't have a 7. Oh, we didn't write down those. But this must be 5, 8, I believe. 5, 8 is 13, yeah. Plus 9 is 22. This can't be a 9 because of this 9. And this 21 cage can't have an 8 because we have these 8s looking in. So this must be... Oh, I don't have that written down either. Whoops, I'm writing down all the wrong stuff, I guess. 9 plus a 12 pair, and it can't have an 8, must be 5, 7. Because it can't have the 9, it can't have the 8, so it must be the 7. And there we go. I think we've done that. Oh no, we have a 5 right here, so this is 5, 9. Okay, now we can do the same thing over here. This can't have a 2. So it can't be 1, 2, 6, it must be 1, 3, 5, which puts the 5 there, 1 there, and a 3 there. Nice. Yeah, that was super smooth. I just was very slow to notice the interaction there, which then propagated so much. Okay. So 13 cage, can't have a 5, can't have a 9, can't have a 2. So it's either 1, 4, 8, or 3, 4, 6. Or is there even there's a 3. This would be, so this is a 1 or a 3. And there's always a 4 in here. And it's either a 6 or an 8. Okay. Maybe that's not exactly where we need to look. Let's look here because we almost finished this row. We need a 4 and a 6. Well, that doesn't help either. Actually, let's leave it. I was going to delete all of it, but we shouldn't delete all of it. Maybe 17 would help, or... So this is a 9, and then a 6 or an 8. Whichever one we don't use inside the... Whoops, inside of the box here. Oh, you know what? Maybe 5. 5, 5, 5, 5, 5 puts a 5 there. 5, 5, 5, 5 puts a 5 there, which means this is not a 6. I don't know if that really helps, but that's not a 6. We have a 2 along here. Guess we similarly have an 8 along here. We have a 7 along here. That's not really helpful. I keep double checking all the options that cells here that I have to see if I'm just missing something dumb like before. Okay. Oh, this one just can't be an 8. What am I doing? Could this be a 6? I don't think this cell could be a 6 even. Excuse me. If this was a 6, that would mean it must be 3, 4, 6. Which means this must be the 4 and this must be the 3. So this can't be a 6, this must just be the 4. It doesn't tell us which option it is, but it does give us a digit at least. Not a super helpful digit, but a digit nonetheless. Yeah, okay, what about down here, 17? Let me copy these 17s. So many options, so many options. Okay, so it can't have a 5, that's the first one we can easily rule out. Can't have a 1. Can't have an 8 either, so that removes all but the last 2 options. Great. So this cell is either a 7 or a 9, which means one of these is a 6, just the same as this up here. And this is either a 2 with a 6 or a 4 with a 6. And this can't be a 2, so could this actually be a 4? If this is a 4, this is a 6, which means this must be the 7. And that breaks it, so this can't be a 4, this is just a 6. And I didn't get any progress here, but let's just double check this. We have the 5, so the 7 is in one of these corners. That doesn't really help. Same as the 3 up there. But this is, whoops, 1, 2, 4. And this can't be a 4 because of the 5. But besides that, not super helpful. Okay. But we've basically done everything except for just consecutivenesses. So let's just keep working on that. Oh, you know what? And I immediately see something. Where can 6 go in this row? Obviously, it can't go where we've already typed in digits, but it also can't go here because of the 5 that we have. 6 is consecutive with 5, of course, so 6 goes along here, which means this is not a 6. This must be a 4, this must be a 6. And actually, we have a 6 there, so that can't be a 6 either. And we can do kind of the inverse. 4 is ruled out of this cell because of the 4 up there. We have a 7 up here as well. 7 can't go down here because of the 7. Actually, this is 6, 7, 9 up here. Because this 6, 7, 9 can't be down here. So we must have a 9 buffering between the 6 and the 7. Don't think we have the information of what's there. This is a 2 and an 8. This must... Whoopsies. I don't know if that popped up on OBS or on the recording or not, but I accidentally hit the Windows key. And then I just started typing in digits in, and it started like looking for file names that are like 2, 8 random things. Okay. So this is a 2 or an 8 as well, and is also given. That's going to actually give us maybe a little bit of information, maybe not. Maybe not as much information as I would have hoped. At least not as much, nothing that I see right away. What's here? This is 1, 4, and 3, so the 1 buffers. Just like over here, yeah. Okay. Let's see, what else can we do? Yeah, let's look at these columns because there's not very much left here. 1, 2, 3 must go into one of these two because of the 2. 4 can go anywhere but there. Or it can't go there either. 5 is already given. 6, 7 must go up here. And then 8 can't go there and can't go there. So is this literally just 7? Let's just double check this. Can't be 1, can't be 2, can't be 3 because of the 2. Can't be 4, can't be 5. Can't be 6, we already have 6. Could be 7. Can't be 8 because of the 9, and can't be 9 because of the 9. So this is just a 7. Nice, okay. So let's look at this cell. Can't be 1, can't be 2 because of the 1. Could be 3, 4, 5, 6. Can't be 7 because of the 8. Can't be 8 because of the 8. Can't be 9 because of the 8. So this is just a 3, which then looks over at this. Nice. This is a really nice non-consecutive puzzle. I'm really enjoying this. Sometimes non-consecutive can be a little tedious, where you're just like looking through all the different options, but this is flowing super well. And like the places that you think to look are the places you should be looking. So besides me being dumb there, which is totally my fault, this is going very smoothly. Yeah, that missing that was obviously very silly. Looking at an option, like looking at a consecutive pair like this, like in a non-consecutive puzzle, you should immediately be looking here and being like, oh, this can't be a 3 or a 4 because you have a 3-4 pair there. Like that's just like very um like very early on logic that you should be thinking about for non-consecutive puzzles, and I, for whatever reason, just was not. And like I said, this can't be a 4 because of this, so this is, or because of this. This 3 actually is better. Rules out 2 and 4, so this can't be a 7, so this is a 2, 4 over here. So this is a 6 because it can't be a 7. Oh, what's left is 2, 4, and 1. Um, could that? Oh, this can't be a 4. So one of these is a 4, which means this is a 3. This is a 4. Oh, there's a 2 right here. I was gonna say, like, there's too many digits left over in this column. Like, there needs to there needs to be something else going on, because there's more digits left over than there are spaces, and I just didn't see the 2. Yeah, I'm coming down home stretch. This was a great puzzle. Thank you very much to MicroStudy for this puzzle. Very well made. 6, 9. Do we have any? Oh yeah, we do. Of course, it's a non-consecutive puzzle. Literally both of the digits that I was, whoops, was next to had information on that. So this is 7. Excuse me. Of course, wrapping up the puzzle, I have to clear my throat. Oh, that's interesting. I mean, I guess that makes sense. They're equaling, or like they're opposites or whatever. But it's still kind of funny that both 4, 6. What am I missing? 9. There we go. That was not too difficult. I made it a little bit more difficult on myself just by being um, unobservant, I guess. But that flowed super smoothly. That was a great puzzle. Thank you very much, MicroStudy, and thank you all for watching.